just about soil types. All right, so just going to run through a quick PowerPoint here, all right, with some little bits. You can head up a page with that. You might make one or two little notes, and then I'll be going through an assignment which is a little bit tricky, so you'll need to pay close attention to it. Okay, I'm going to mention quite a few little bits and pieces as well, which will help with that assignment. So again, our soil profile. All right, so you can write down this is the layered structure of the soil and is made up of different horizons. Now, we looked at A, B, and C. To be completely honest, A, B, and C is all you really need. All right, this one here adds in O, E, and OR. Now, again, in my opinion, A, B, and C is plenty. One that I would write down, you can add O. Okay, so this is the organic or humus layer right up on the top here, where all that decaying matter filters down into the soil. A, B, and C then you can add. All right, so I just want you to write down these little bits beside it. Now, or it says it's the bedrock. You can also say that for C. Okay, so don't worry with E and or, but put down A, B, and C, and you can add O as well, which is the very top layer. Okay, you can see O for organic over here. So that's just your soil profiles again. All right. Now, just to run through what some of them look like, we're going to look at a couple of different types now, two in particular. All right, so you got these things called laterites, which bright red soils. Okay, you can see there. So again, thinking back to our geology from last year and stuff like that, we know when iron minerals are leached down or filtered down or pulled down into the soil through water, okay, they leave a colouring in the soil. All right, so these would have a high iron content. That's why they're red. The next one is podzols, and again, this is a lot more earthy browns, okay, to sandy grey yellows. All right, you can see the kind of grey yellowy color there. Again, you can start to see the clear layers. Okay, we've got organic matter up here, A, B, coming down to C. You'll also notice how they've reached water down in this one here. Again, vegetative matter, okay, coming down through our layers. This one is a good example here. This is what a humus layer would look like. Okay, lots of broken down material here, quite nutrient rich, and you can see where it's starting to filter down through these layers then. All right, so these are what some of the horizons look like. There's two others called chernozems. All right, again, very simple, and latisols, which look kind of like laterites. Now we're just going to look at these two today, okay, laterites and podzols, and they're going to help you with your assignment. All right, so moving away from the PowerPoint, you've been sent an attachment, okay, that starts off with a sheet about laterites, and podzols, and it goes down through chernozems and latisols as well. Okay, there's all sorts of questions and things. Don't worry about them just yet. We are going to look at podzols and laterites to begin with. Okay, now very simple. You will see the same headings: form, process, human content, soil profile. Okay, you'll see those and locations and agricultural productivity. Again, characteristics, form, profile, location, so on. Okay, a couple of things to run through here. All right, form. So what you can do is just highlight under forests. Okay, humid, wet, tropical conditions. Okay, so hot and wet. So these will form near your rainforests, near the equator, and so on. What is the process? Chemical weathering. I just talked about iron and the chemical weathering of how it shows up red. Okay, chemical weathering and biological decay of organic matter. That's your humus layer. Is rapid. So highlight rapid. Okay, and the weathering extends to great depths. So we got chemical weathering. You can add red and iron above that, and then rapid. You can put humus above organic material. All right. There's a lack of humus in the soil profile. All right, so because it's so hot and so wet in the, I know it says dry there, but we're going to look at the hot and wet climates. Okay, because it's so hot and wet, the humus breaks down very, very quickly and down into the soil. Okay, so there's not a big layer on top. Then you got your soil profile. Okay, heavily leached, horizon A. Leached, again, a lot of rainfall, so that rain seeps down or moves down through the horizons, down through the soil, taking all the materials deep down. All right, abundant rainfall leaches nutrients. Now, iron and aluminium remain after leaching and give these laterites a reddish brown colour. So you need to highlight that bit as well. This is important. All this is very important for your assignment. When natural vegetative cover, soil A horizon is open and permeable, water can infiltrate easily. Okay, so that's all we're going to look at, those little few bullet points there. Location, you can highlight the locations: rainforests and savannas, so Southeast Asia, parts of Africa, South America. These are mainly found in your rainforests, which again I think is important for your assignment. Okay. Agricultural productivity and other uses. We're not going to go through that just yet. We'll come back to that when we look at soil conservation. Okay. And then come down to podzols. Let me just check and see if there's characteristics back up here. Lovely. Okay, so this time, characteristics of podzols. I want you to highlight this: found in coniferous forests, boreal regions. So you can say cold climates. Above coniferous, you can put in pine trees or Christmas trees. That's what coniferous trees are like. Coniferous forests and boreal regions are cold climates. So please put that there. So grey-brown soil, okay, acidic, highly acidic. That's important for your assignment as well. Horizon A gets leached a lot as well. A lot of the material moved down quickly to B, horizon B, and a thin soil. All right. So form under coniferous forest vegetation. Okay. Temperatures ranging from warm to cold. Mainly cold climates. Now profile. So what's its profile like? What are the horizons? Grey podzols have a substantial A horizon with organic matter. Okay, and decaying materials. So they've got a big A horizon. In cold temperatures, decay is slow, leaching is very active. You have to highlight that, okay? Decay is slow, leaching is very active. That will help with your homework. Part A has been leached of all nutrients and sand remains. So the top one is kind of a yellowy colour, all right? Yellowy brown with very few nutrients, all right? Locations: coniferous soils, eastern, highlight Canada, Appalachian Mountains, okay, and Georgia, southeast USA. Again, I'm not going to go into agricultural productivity just yet. All right, but you just need to know these kind of characteristics, these kind of bits here. All right. Once you've gone through those 2 pages, we're going to go to our assignment page. Now, I'll attach this to your assignment. All right. On Plus Portal. So, first bit. Let me just zoom in a bit. Okay. Down the bottom of this page, you will see that there's questions 1 through 5. 1 and 2 are up here. This is 1. Okay, A is about 1, B is about 2. So, question 1 says, in figure A, match the soil characteristics to the correct definition. You've got parent material, leaching, soil horizons, soil profile, weathering, and humus. You need to match each. You need to write these out under where you've headed up, and then match them to one of the definitions. Okay, shouldn't be overly difficult. You can use Bunnet and New Wider World to find those if you're confused, but you should have made a note of some of these today and yesterday. That's an easy one. Now I'll come back to number 2. Number 3 says, give 2 reasons which explain why tropical rainforest soils are much deeper than podzol soils. Okay, actually, sorry, I don't want to do 3. We haven't done that yet. Don't do 3. Okay, so you're going to do 1, 2, 4, and 5. So I'll come back to 2. Number 4 says, why is the rate of plant decay so much faster in tropical rainforests than in podzols? Beside that, you can write down climate. So why do things decay faster in the rainforest than they do in the cold climates where podzols are? What is the climate like in rainforests that speed up decomposition or the breakdown of plants? All right, very simple. And number 5, both tropical rainforests and podzol soils are relatively infertile and have little value for farming. What has made these soils infertile? So again, think here about the humus layer in tropical rainforest. What happens to the humus layer, right, and the nutrients made from that? And then also think about podzols, all right, where are they found, what type of vegetation is found on them, do they have a lot of nutrients or not? Okay, so that should be quite easy. 4 and 5 are worth 2 marks each. Number 1 is worth 5, I believe, 6 marks. Now number 2 is tricky. Okay, so it says place the notes, these notes, on the horizon, on the soil profiles properly. Be very clear. Look, tropical rainforest soil, podzol soil, podzol, tropical rainforest. Okay. Now, this is the top. This would be the surface, ABC, ABC. Now we're going to have to change tropical rainforest because, as you can see, there's 7 boxes and only 6 spaces. So what I would like you to do is draw a little line across. I don't want to draw on my screen, but you draw a little line across here to break up the last one. Okay, a little line where my pen is. So you have 1, 2, 3, 4 areas on the tropical rainforest one. All right. Now I'll run through some of this together. Let's start at the top. Okay, where the humus layer is and leaf litter. These should be fairly easy. Okay, so let me just see. We got 2 things about leaf litter. Okay, leaf litter is going to go right at the top. Okay, leaf litter from rainforest trees. Okay, then you've got leaf litter, acid leaf litter from conifer trees. So now this one is about rainforests, so that one will probably go in there. We know podzols are covered by coniferous forests, so that will go up here. Okay, now we've got breakdown and decay, rapid decay of leaf litter. So where does leaf litter and humus decay or break down rapidly? Here or here. That will be the next one. Acid humus layer, slow breakdown of leaf litter. Where does it happen slowly? Look back at the worksheet we just went through. Then these last ones, very easy. Okay, I've pretty much done the first 4 for you. The last ones then, think about the colors. Okay, ash gray, sandy horizon with few nutrients. Which one is that? This one talks about bright red soil. Which one is that? Okay, and again, this one talks about aluminium and iron are washed down from above to accumulate to stay here. So these here, you can number them 1 to 7 and put the numbers 1 to 7 on here. But this is your surface moving down through the horizons. Alright, so have a go at that worksheet. You can do all the answers. You can do these out on folder sheet. You can draw these on folder sheet with that on it, and answer 4 and 5 on folder sheet. And then again, submit it to me through Plus Portal. Okay, any questions, get me on WhatsApp.